All right, guys, so we're going to go over the review sheet today. We're going over the review today. So the first thing we're looking at is problems 1 through 6. 1 through 6, describe the transformation. So when we look at these here, we're wanting to describe the transformation of the function. Now, I did include in the back, after the answer key, kind of the general form of the transformation of these quadratic functions. I didn't go into specifics with kind of h, or for a, if it's greater than 0 and less than 1, it's a vertical shrink. If it is greater than 1, it's a stretch. And if you want to add those into that part, go on and do it. Add the notes that you need to help you out. Now, specifically, are there questions on 1, 2, 3, 4, 5, or 6? One of those in particular that y'all want to look at? 1. Now, if we look at 1, there's 3 different transformations being applied. Because we have the 2/3, we have the -2, and we have the +3. We have these 3 different transformations occurring. Now, if we look at the 2/3, that's in the place of a. It's outside the parentheses. If it's outside the parentheses and being multiplied, we know that this is a vertical shrink of 2/3. And again, vertical's not too hard to see or kind of determine what you're talking about, but again, I would make sure that your stretch or shrink is obvious which one it is. Because if it looks like shrink, or I think it looks like shrink and it's supposed to be stretch, I'm going to mark it wrong. If I think it looks like you wrote stretch and it's supposed to be shrink, I will mark it wrong. So make sure it's clear which one we're looking at. Now, that takes care of the 2/3. Now, since it's not negative, we don't have a reflection. Is in that spot, that's where we look for reflections. Inside the parentheses, there's no sign with X or number in front of the X, so there's no horizontal stretch or shrink or reflection across the Y. Now, the -2 tells me we're going to have a movement of 2 units which direction? To the right. Yes, inside the parentheses is the opposite of what we think. Since it's -2, we're moving to the right 2. And lastly, the +3 is up 3. And that's it. That's all we're looking for on this here. Any other questions on 1? Is there another one on 2 through 6 that we want to look at? 3. Number 3, so we have negative, parentheses, negative x, close parentheses, squared. So we have 2 negatives. Those are going to be our movements. Now, the negative outside the parentheses is a yes. So, do we have another number other than 1 anywhere being multiplied? No. So that negative outside is just a reflection across the x-axis. It's nothing else. Now, the negative inside the parentheses in front of x is another reflection, and this time it's across the y-axis. Yes. Well, we actually have both. Because inside the parentheses is across the y, outside the parentheses across the x. So this one here had both. Now for us here, the reflection across the y-axis really isn't going to do a thing. Because it's going to put all the points, the y values that are on the right side of the graph, over to where the left ones are, and all the ones on the left are now where the right ones are. So it just mapped it onto itself. But that's it. Now, because there's not a number in front of the x, there's no stretch or shrink, it's just a reflection. So if you want to put that note, especially on the back with it, that negatives are just dealing with the reflection, it might be helpful. Any other questions on 4 through 6? We can come back to them later if we need. 7 through 10. Find the vertex and axis of symmetry. Do we want to look at 7 or 8? because these here are actually both the same. 7 and 8 are the same deal. Both of these are in the vertex form, which is our a times x minus h squared plus k. And the vertex is the point h comma k. H is inside the parentheses and k is outside. So here, inside the parentheses, we have minus 1, which is going to come out as 1. Just from the formula, x minus h. So we have x minus 1. So h has to be positive 1. Plus k, plus 5. So k is 5. Axis of symmetry, x is equal to h. So x is equal to 1. And I did include these forms in the back for y'all. So I'd be referencing back to those there, looking back at the formula, how does it match up? Well, we can go on and do this here because it's not too bad. Vertex is going to be what? Almost. Negative 1 and 2. Since we have plus 1 inside the parentheses, h is negative. Axis of symmetry. X is equal to negative 1. I would really like for y'all to label these, which one's vertex, which one's axis of symmetry. I will count off if you don't put x equals for these axis of symmetry. If you just put axis of symmetry negative 1, I am going to count off. Because the axis of symmetry is an equation of a line. It is the actual equation that we're dealing with, not just a value, a number. So we would need all of this here. Any other questions on any of this here? Now, these two here are standard form. Ax squared plus bx plus c. Yes, here the vertex is negative b over 2a comma f of negative b over 2a. So here, negative b over 2a. Well, this is a, this is b, this is c. So b is negative 4 and a is 6. Now at this point here, you can type this all in the calculator. If you're worried about signs, mixing up the signs or reducing wrong, plug it all in. So here we could say alpha y equals enter negative 4 over 2 times 6. Type it all in. Could we get whole numbers on this? Yes. Can we get fractions? Yes. So 1/3. So it tells me that this is 1/3. So the vertex is 1/3. Now the axis of symmetry is an x equals 1/3 because the axis of symmetry, I'll have to erase this in a little bit, x is equal to negative b over 2a. And again, I have that down in the back. After the answer key, it's there for y'all to reference. Now the only other part that we have to do is take this 1/3 and plug it back in to find the y value of the vertex. So we're looking at 6 times 1/3 squared minus 4 times 1/3 plus 5. And again, type this into the calculator. Type it in. Six parentheses alpha I equals enter 1 over 3 close parentheses squared minus 4 times even though it's going to be at 100% for all time. But we get 13/3. Yes. So it's 1/3 comma 13/3. And again, with the axis of symmetry, we're going to need x equals. For the vertex, we're going to need both of those points. Questions on this here? Okay, I'm going to erase this here so I have a little bit more room to write. Here, vertex is still negative b over 2a. So negative 14 over 2 times 1 is what we'll be plugging in. Negative b over 2a. And again, there's nothing wrong with doing negative parentheses, negative 14 close parentheses over 2 times 1. Typing it in just like that. And letting the calculator do it. Because we don't get any extra points for saying, oh, negative 14 is positive 14. If we keep that straight, awesome, we'll get the right answer. Typing it in like this, we'll still get the right answer. And it'll tell us that this is 7. Well, we can go on and say what the axis of symmetry is. X is equal to 7. Now the only other thing we have to do is plug it in, so 7 squared minus 14 times 7 plus 20. And solve from here. 8. 69. And I believe it should be negative 29. 7 comma negative 29. But again, you could plug that into a calculator and let it do it for you. Seven squared minus 14 times 7 plus 20. Negative 29. You don't have to do this by hand. But I would at least write it down. At least kind of showing where you started. That way you can plug it in and see what you're getting. Because that sometimes helps to look back at. Any other questions on 9 or 10? We good with 9 and 10? 11 through 16, we want to find the focus, axis of symmetry, and directrix, and vertex. I'll just go and throw the vertex in there. Because what do we know the vertex is for all these here that we covered? It was the same thing every time. 0, 0. We never moved the thing away from the vertex. So for all of these here, the vertex, even though it wasn't included, is going to be the point. Yeah, I'd go and put that in there. I mean, that's kind of nice. I threw that in there on the test. I mean, that's going to be easy points because the vertex will always be 0, 0 for these here. I took out the parts of this year for the ones that aren't going to be 0, 0. Not because it's hard. There's just some I didn't want to trudge through with that with. Not in here, but there are some. So, vertex is 0, 0, yes? Now, this is y equals 1/32 x squared. And in our two general forms, the variable without the exponent has to be by itself. Is it by itself here? Well, yes. So that means we can go on and start solving. So when we look at this one here, again, I would look back to the general form. Which one do we have? Because if we look at the two general forms, here we have y equals, so the focus is our point 0, comma, p, the value of p. Our directrix is y equals negative p. And our axis of symmetry is x is equal to 0. Axis symmetry, yes, because it's not away from the vertex. If we move this vertex away from 0, 0, then the axis symmetry and the x value of the focus would have a different value. So really all we need to do is find the value of p, and then we solve it, plug it back in. Well, y is equal to 1 over 4p x squared. So the value of p should be somewhere in the 1/32nd, because that's where the p value is located. So what we're doing is we're setting 1 over 4p equal to 1 over 32. And the first main step has always been the same. We're going to multiply both sides by 4p because those will cancel. And really give us that 1 is equal to 4p over 32. Now you could have multiplied the 4 times 1 over 32 in the calculator, let it simplify it for you, and it'll just tell you that it's p over 8. Now at this point here, we could divide both sides by 1/8 to get to the answer, or we can multiply both sides by 8, because here the 8 and 8 would cancel out, telling us p is equal to 8. Yes, or we can multiply by the reciprocal of the fraction. So here it's 1 over 8. So if I flip it, it's just 8. I'm saying like for 2. Yeah. So if we had, say, 2p over 3, I could multiply both sides by 3/2. I just took 2/3 and flipped it. They would simplify, and we would get the other side. Questions on this here? Well, the focus is 0, p. Well, p is, so it's 0, 8. The directrix is y equals negative p, so y equals negative. And that's it. So besides matching it up to the correct form, there's only really 2 things we had to actually solve for. Any questions on this here? And again, really just matching it up to the correct form gave us over 80% of the answer. We just had to solve for those last 2 parts. So even if you get stuck on this tomorrow, I would at least write down, figure out which is the correct form and fill all that in, and then try to figure out the last bits last. Any other questions on this here? Any other questions on 11 through 16? Any of those that y'all want to look at? So 12, 13, 14, 15, or 16, one of those in particular that y'all want to look at. 14? Negative 3x minus 4y squared is equal to 0. So we need to get these on opposite sides, yes? Now, the one that's squared, we don't really care about its sign, because we need, in both general forms, x or y. The one without an exponent has to be positive, yes? Why don't we move it first? Because we do need to get it by itself. So we can add 3x to both sides. Really telling us that 3x is equal to negative 4y squared. They're on opposite sides. I did flip it, because we did add 3x to both sides, and then I flipped it just to make it look nice. Does that make sense? Because I moved the 3x over and then flipped the equation around. Now the x is still not by itself, so we're going to divide both sides by 3. Because 3x divided by 3 is just x. Here, we're going to have negative 4/3 y squared, or negative 4y squared over 3. I keep the y over to the side because, again, what's the main thing we need to find for this here? The value of p. And it's going to be nicer to match up if we don't have the y squared up in the numerator. Okay. Vertex is what? Vertex is 0, 0. For all these here, it's 0, 0. That's just the general form. Because we didn't move it away from the vertex, vertex is, or from the origin, vertex is 0, 0. Now, because the y is being squared, the focus is exactly p comma 0. Focus is the point p comma 0. The directrix is the equation x is equal to negative p. And the axis of symmetry, y is equal to 0. I will tell you all right now, I'm being awfully generous with these problems here. Because vertex, focus, each one of these is worth 2 points. As long as you got both sides, both parts there, you get the full amount. And I mean, just with this here, I've already got 2 points for the vertex. I got a point for the focus. I've got a point for the directrix having the correct equation. And I've got 2 points for the axis symmetry, correct the fact that it's y equals and 0. How many points am I missing? 2. Because I'm missing the x value of the focus and the other side of the directrix. So what, 7 out of 9? Because you get a point for doing it. It's going to be negative. It's going to be opposite of whatever the focus's p-value is. Now for us here, the p is located in the negative 4/3, yes? So what we'll do is set negative 4/3 equal to 1 over 4p, because that's where p is located. Because if we plug the value of p into 1 over 4p, we should simplify it out to be negative 4/3. Now the first thing we can do with this here is multiply both sides by 4p. And here these will cancel, leaving us with 1. Now on the other side, we're going to get negative 16p over 3. Now what do we do next? Well, we could divide both sides by negative 16/3, negative 16 over 3, or we can flip that fraction. I can multiply both sides by negative 3 over 16. Either way works. Because if we divide both sides by negative 16/3, we get 1 over negative 16/3 minus p is negative 3/16. Because really we're wanting that to cancel out. 16/3. And the reason that we can flip it and multiply is we multiply it straight across. So it'd be negative 16 times negative 3 over 3 times 16. If we did the flip, well, the negative and negative make a positive, yes? Here we've got 3 over 3. That would be 1. 16 over 16 is 1. So we could have flipped it and multiplied and got negative 3/16. Or you can do 1 over negative 16/3 in the calculator, hit enter, and they'll tell you it's negative 3/16. Does that kind of make sense? So the focus is negative 3/16, comma 0. And the directrix is negative 3/16. Negative 3/16. Well, negative and negative make a positive. So we can just erase it and say 3/16. Or what you could have done with that negative out front, kind of made it part of the fraction and done 3 over 16, kind of erasing it out. Either way works. Questions over this here? All right, let's look at the next one. Are there any other questions over this here? Okay, that should have been good. For problems 15 through 16, find the equation from the given information. So here they gave us the directrix and focus, yes? Well, looking at this here, I have a value comma 0 and x equals negative 1/4, yes? Well, the x equals negative 1/4 kind of gives it away. The fact that I only have a value in the x spot, p comma 0, here x equals negative p, that matches up to one of the set equations, yes? Because if we look at the set equations, that means we're looking at x is equal to 1 over 4p times y squared, because that's just the general form. Now, what is the value of p for this here? 1/4. Because directrix x equals negative p, x equals negative 1/4, so p is 1/4. 1/4 comma 0, p is 1/4. So x is equal to 1 over 4 times 1/4 times y squared. P comma 0, 1/4 comma 0, p is 1/4. At this point here, I would type the 1 over 4 times 1/4 in the calculator. Let it do it for you. And it turns out to be 1. So x is equal to y squared. And that's it. Because for these here, all you're doing is trying to find the value of p. Once you find the value of p, plug it into the correct equation and simplify. And that's it. There's the equation. Let's look at another one. Let's look at 17. Vertex is 0, 0, directrix x equals negative 2/3. The fact that the vertex is 0, 0 tells us nothing, because both forms of this equation, the vertex is 0, 0. But the directrix x equals negative 2/3 tells us everything, because only one of them has a directrix of x equals. And that is our x is equal to 1 over 4p times y squared. And the directrix in the general form is x is equal to negative p, yes? What's taking the place of negative p? Negative 2/3. So what's p? Positive 2/3. Because if negative p is negative 2/3, positive p is positive 2/3. Plug it in. Once we find p, plug it in. X is equal to 1 over 4 times 2/3 y squared. Type that into the calculator exactly as you see it and hit enter. Let it do it for you. And it'll tell you that fraction's 3/8. Because all you do is 1 over 4 times 2/3, and we get 3/8. Questions on this here? You good with this here? Yes? Any other questions on these here with vertex and focus and directrix? Equals 1 over 4p x squared. Yeah, I just pick the correct form and then see, match up, where's p? What's the value of p? And plug it in. If there's no questions on those there, I believe it brings us to this here, 20 through 24. Through 24. Yep. Okay. Yeah. So this here is 2.4. 2.4. And again, I don't believe I specifically wrote this in. You still have the equations and what they are, but I didn't specifically write the equation or kind of specifications for this here. Now, if we look at, I'll go on and just do the first one here. We want to find the equation. What did they give us? They gave us the vertex and a point, yes? So what's the vertex form of a quadratic? Y is equal to a times x minus h squared plus k, because I did give you this form, because we've used it already once to find the vertex in axis of symmetry, yes? Now they told us what the vertex is, 2, 4. So I can plug that in. A times x minus 2 squared plus 4. We're 2/3 of the way done, aren't we? Because all we need to do is find the value of A. So I would at least write this down. Even if you don't get anywhere else, I would at least get to this point here. Because we're 2/3 of the way done, yes? And we do have it in almost the correct form. We just need to find A. To find A, we take 0, 6 and plug it in. We plug 0 in for x, 6 in for y. Saying 6 is equal to A times 0 minus 2 squared plus 4. At this point here, we can solve for A. Now the first thing we can do with this here is 0 minus 2, which is negative 2 squared plus 4. Negative 2 squared, negative 2 times negative 2 is a positive 4a plus 4. Do not combine 4a and 4. They're not the same. We can't just add those together. So what we have to do is we have to subtract 4 from both sides. Because we need to solve for a, we need to get it by itself. So what that will tell us is that 2 is equal to 4a. And the last thing we can do is, by 4, telling us that a is 1/2. Any questions on how we found the value of a? If you leave it as this point here, you're going to lose a point. Because again, we need to rewrite the equation. We need to write the equation with a in it. So y is equal to 1/2 times x minus 2 squared plus 4. This here is your final answer. Once you find a, plug it back in. Once you find a, plug it back in. And that's it. That's all we have to do for this here. Huh? We good with this here? Yes? Any other questions on this here? Nope, it has to be x. It has to be x, it has to be y. We have to have it in terms of x and y. Okay. Any other questions on this here? Is it because it asks for the equation? Yes. Let's look at this one here. 21. Now this one here, it gives us 3 points really. These two here are x-intercepts. The reason we know that they're x-intercepts is because the y value is 0. Now some of it might tell us that the x-intercepts are these two values, then those are the values of the x-intercepts. So here, y is equal to a times x minus p times x minus q. This is the x-intercept form of the quadratic. Now, because it told us the 2 points, this is p comma 0. This is q comma 0. So we already know most of this here. A times x minus 14 times x minus 2. Well, the negative 14 is going to become plus 14. Bless you. Any questions on this here so far? Now again, we're going to plug negative 10, negative 72 in. Negative 72 is going in for y is equal to a times negative 10 plus 14 times negative 10 minus 2. We just plug negative 72 in for x and negative 10 in for, negative 72 in for y, negative 10 in for x. Now all we need to do is solve for the value of a. Well, negative 10 plus 14 is 4. Negative 10 minus 2 is negative 12. Now 4 times negative 12 is negative 48. Okay. And last but not least, we need to divide both sides by negative 48. Now one thing we know for certain is that a is going to be positive. And at this point here, we could plug this into the calculator and what is that? 6 fourths 3 halves, I think is what we get. So y is equal to 3 halves times x plus 14 times x minus 2. And that's it. And you don't have to do negative 72 over negative 48 in your head. Just type it into the calculator, hit enter, and let it do it for you. Questions on any of this here? Okay. Because we only have one last thing to cover, and that's the finding the vertex and axis of symmetry from the x-intercept form. Because these are the last ones here we need to look at, and then we are finished with this review sheet. So this one's our A, B, C, D. Now this is in x-intercept form, and the general form is y is equal to a times x minus p times x minus q. So the values of p and q are here, all 3 and negative 14. So the easiest one to find is the x-intercepts. It is A, B, C, D. Now the x-intercepts are p comma 0 and q comma 0. The y values for any x-intercept is always going to be 0. Now one of the values here, so, is, negative 14. Since it's x plus 14, it's going to be negative 14. X minus 3 tells me that this is 3, because the values of p and q are negative 14 and 3. Now the vertex is p plus q over 2, comma, f of p plus q over 2. And again, these here are included at the back with the rest of them. So to find the x value of the vertex, we're going to add the p and q values together and divide by 2. So we would have negative 14 plus 3 over 2. And again, we can plug this into a calculator and let it do it for us. Then it'll tell us that it's negative 11 halves. Which is kind of nice to know, because the axis of symmetry, x is equal to p plus q over 2. Well, p plus q over 2 is negative 11 halves. questions on this so far? Really all we've done is what? Found P and Q, plugged it in for the x-intercepts, plugged it into the equation to find the x value of the vertex. And the axis of symmetry has the same value as the x value of the vertex. That can win. Now the y value here, we have to plug it back in. We have to plug it back in to the equation. I will call him back. So here is going to be negative 7 times negative 11 over 2 plus 14 times negative 11 over 2 minus 3. And again, at this point here, I would type the whole thing in. Type it in exactly as you see it into the calculator to let it do it for you, instead of trying to do this in individual parts. So I'll go back to it. I will go back to it here in a second, because we have negative 7 times alpha, y equals, enter, negative 11 over 2 plus, yes. Hold on 1 second. Let's finish this up here. Over 2 minus 3, enter, and we get 3 over 4.
I would see that and I'd be like, that's fine.
Yeah, I'd be like, I would just give up at that point. I would literally cry.
And again, just trust your answers on these here. Just because they look big or weird fractions doesn't mean they're wrong.